Hello Math 95 students, we are on section 13.3. So 13.2 was about how to simplify radical expressions by adding, subtracting, or multiplying. This section is about how to simplify radical expressions that involve dividing. So you know the fraction bar means to divide, so that's why these radical expressions are involving division. The main thing to keep in mind with dividing radicals is you can't have a radical in the denominator. We don't want to have a radical in the denominator. That means we don't want to have a radical on the bottom of the fraction. So at least that's not the preferred or standard way to write this. So we want to get rid of the radical on the bottom of the fraction. But we want to do it in such a way that it does not change the value of the fraction. So how do we do that? Okay, if you multiply the square root of x times the square root of x, in other words, you multiply the square root of something but with itself, what do you get? You get the square root of x squared. So you get the square root of that thing squared. And what is the square root of that thing squared? Well, that's x times x, and that's a pair, and that's what you want. It comes out. Or another way to think of it, the index, the invisible index of 2 cancels out with the exponent of 2, and either way, you just get x. So if you multiply a radical with itself, in other words, or let me just say it this way, if you multiply a square root radical with itself, you're always going to get, the result is just going to be the radicand. It's just going to be the thing under the radical. Let's keep that in mind. If you can keep that in mind, it'll make this a lot easier for you. So if we want to get rid of that radical on the bottom, then we're going to multiply that radical with itself. So I'm multiplying the square root of 3x with the square root of 3x. And I can do that without changing the value of the fraction as long as I do the same thing to the top that I do to the bottom. So I also have to multiply the 4 on top with the square root of 3x as well. So now what do we get? We get on top, we get 4 root 3x on top. And on bottom, the square root of 3x times the square root of 3x. We've already said what that is. That is 3x. Okay? I can prove it to you. Square root of 3x times the square root of 3x is the square root of 3x times 3x is 9x squared. And the 9 breaks down to 3 and 3, so that's a 3. And the x squared, you take that invisible 2 and put it right there, and so that's going to come out as an x. So it's just 3x. But maybe you didn't need to say that because you already believed it or already knew it. So that is going to become 4 root 3x. There's nothing I can do to the top there, but on the bottom here, the 5 and the 3x can multiply on the bottom and get 15x. And that's my answer. Okay, we're going to have something similar happen here. Notice that we have a radical symbol over the entire fraction. When that's the case, just break it up into its numerator and denominator, both of them being under the radical, under a separate radical. So instead of the square root of 5 over k, I've got the square root of 5 over the square root of k, which is the same thing. And how do we get rid of the radical on the bottom? The only thing we don't want is we don't want a radical on the bottom. If we get rid of the radical on the bottom, we're done. You multiply it with itself, as we said earlier. And as long as I do the same thing to the top that I did to the bottom, then I'm good. So multiplying by the square root of k on the bottom and on the top. So on the top, what do I have? I have the square root of 5 times the square root of k. Both of them are under the radical. So it's going to be the square root of 5k, with both the 5 and the k being under the radical. On the bottom, what's the square root of k times the square root of k? It's just k. And that's my answer. All right, in this section, for the purposes of this class, we are not going to worry about doing these radicals when the index is anything other than a square root. Okay, this example is different. If we have a plus or a minus going on the bottom, then we can't just multiply the radical with itself, because we're multiplying the whole denominator by the thing. So it's not going to help to multiply this by the square root of x, because then that would distribute to the 3 and we wouldn't be rid of the radical at all. So what you do is you use a bit of that something we discovered in the previous section, and that is, if you multiply a radical expression by its conjugate, you will end up with a result that has no radicals in it. So that's the trick. You're going to multiply this radical expression on bottom with its conjugate. Do you remember what the conjugate is? If we have a plus b, the conjugate is a minus b. If we have m minus n, the conjugate is m plus n. So all it does is change the sign of the second term to make the conjugate. So 3 plus the square root of x, the conjugate of that will be 3 minus the square root of x. And I do have to do the same thing to the top. I have to multiply the same thing on the top that I multiply on the bottom. So now let's go with the top. Distribute that, and you get 15 minus 5 square root, what is going on here? Minus 5 square root x on top. On bottom, let's FOIL this out. That's going to be 9 minus 3 square root x plus 3 square root x minus square root x squared. What happens to the middle terms? They cancel out, and they always will. What happens to this last term? The square root of x squared. We've already kind of said this, but the square root of something times itself is just going to be whatever that thing was under the radical. It's just going to be x. But to prove it to you another way, once again, the index is an indivisible 2, so I put that under there, and that comes out as just an x. And there's nothing left under the radical. So what is this? It is 9 minus x. So that's what goes under here, 9 minus x. And that's it. It's simplified. And notice what I said to you earlier, that when you multiply conjugate with itself, you're not going to have any radicals in your result. So the trick does work here. And I think with just those 3 examples, you have enough information to be able to get your homework problems done. So we'll end it right there for section 13.3. Good luck on that assignment. I will see you again in 13.5.